Okay, so factoring polynomials. So not just polynomials, because I guess this does work for cubics, some third degree with 4 terms, but we're just going to use it with our trinomials, right, our quadratics. So this is going to be our method of factoring quadratics. Okay, and it's a decent method because it works with every single problem. Right, there are other methods that only work with a certain type of problem, but this method works with all problems no matter what. Okay, and it's called the AC method. Okay, so hopefully you learned in your, well, this is your algebra class, already that we can have a quadratic. Okay, a quadratic is one that has an x squared term, and we have 3 coefficients. The coefficient of x squared, aka the number in front of x squared, we call a. And the number that doesn't have a variable, your constant term, is what we call c. Okay? So the AC method means that we're going to multiply these 2 terms together. Okay? AC, A times C. We're going to multiply them together. Multiply. Okay, and I don't know about magic numbers. That's a term that's been thrown around sometimes in algebra education. I don't know how magical they are, but that's what we were working on yesterday. Numbers that multiply to give you this product, right? Multiply to give you that, and also at the same time add to give the number in the middle. Okay, which is why they're sometimes referred to as magic numbers. There's nothing really magical about them, but they do double duty, right? They are a product, and at the same time they are a sum. Okay? And then we're going to do some replacing. Okay, we're going to split our middle term into 2 terms. Okay, and then we're going to factor these things by grouping, which we're looking at greatest common factors. Okay, so we're applying a couple of different strategies that we've already learned so that we can hopefully be able to factor out any type of a quadratic that we're ever given. Okay, so let's look at some examples first off here. I have the quadratic x squared plus 7x plus 10. Okay, so A is the number in front of x squared. Okay, do you see a number in front of x squared? Right? No, we don't see one, right? So if we don't see a number, we can assume that number is 1. Okay, B is the number in front of x, which in this case your B value is going to be 7. And the C value is the one that is the constant. Right, it does not have a variable, which is why it's called a constant. The C value is 10. Okay, so in order to do the AC method properly, we have to identify your 3 A, B, and C's. So then AC, right, A is 1, C is 10. What is 1 times 10? Well, that number is just 10. Okay, so the AC, the product of A and C is 10. Now, the B value is 7. Right? AC is 10. A times C, 1 times 10 is 10, and the B value is 7. So let's think about our multipliers. What numbers multiply to give us 10? Right? They're 1 and 10. 1 plus 10 is 11, or it's 2 and 5. Right? 2 plus 5 is 7. So these are the numbers that we are looking for. These are your factors, the numbers that multiply to give you 7. Okay, so the procedure says we're going to take our 7x, right? We had a 7x here before, and we're going to replace that with these 2 factors. Okay? We're going to change this into 2x plus 5x. Is 2x plus 5x 7x? It sure is. Okay, so we are figuring out those numbers so we can replace. All right, we're going to rewrite 7x as 2x plus 5x. And those numbers come from your products, the ones that multiply to give you 10 and add to give 7. So now that we have 4 terms, we think, what do these 2 terms have as a greatest common factor? What is the GCF between x squared and 2x? And hopefully you see that these both have an x in common, right? They both have a multiplier of x. So if we divide both of these by x, I get an x plus 2 as my leftover. Okay, x plus 2 as the leftover. And looking at these terms, what do a 5x and a 10 have as a common multiplier? Hopefully you see that there is a 5, right? 5 times x and 5 times 2. So they both have a 5 as a common multiplier, leaving me with an x plus 2. Okay, so now we group these ones again, right? We take the 2 black x plus 2's and we factor them out as 1. So x plus 2, this is one of our factors, and then the red stuff gets together as your other factor. So x squared plus 7x plus 10 is factored to x plus 2 times x plus 5. Okay, remember, factors mean things that multiply. So if I take x plus 2 and I multiply it by x plus 5, there's my x squared term. There's my 5x and 2x. 5x plus 2x is the 7x, and 5 times 2 is 10. So you can always multiply the factored form back to standard form. Okay, let's try that again. 2n squared minus 22 plus 20. Okay, so the first thing it always says is, do these terms have a common multiplier? 2n, 22n, and 20 all have a common multiplier of 2, right? These are all even terms, so they all have a multiplier of 2. So divide all of these by 2 and I get 1n squared. 22 divided by 2 is 11n. 20 divided by 2 is 10. So now let's look at our letters. A is the variable in the coefficient of n squared. What's the coefficient of n squared? Well, that's just 1. Right? The parentheses outside don't count. It's only inside of the parentheses. And then our last term, our c value is 10. So if I do my AC 1 times 10, the answer is 10. And my b value, right, b is the number in the middle with the just the straight variable n. B is going to be negative 11. Okay, so from yesterday's notes, we have a positive term here and a negative sum. Okay, so if we have a positive product but a negative sum, that means both of our products have to be negative. Right, so this becomes a negative 1 times negative 10, or a negative 2 times negative 5. If your product is positive and your sum is negative, then both of your factors, both of your multipliers, will be negative numbers. That was one of our general rules from yesterday. So I think we can tell exactly which factors we want. We want them to be negative 1 and negative 10, because those are the numbers that multiply to give you positive 10 and at the same time add to give negative 11. Okay, so knowing that, let's come over and rewrite our quadratics. So 2, right, leave it exactly as it is. N squared minus 11n plus 10. So that's your quadratic. Okay, the 2 stays out front. It is not involved with our factorization. Okay, the 2 stays out front. We split the negative 11 into negative 1n minus and a negative 10n. Okay, so we split that middle term. They both need to have letters. They both need to have your variables. So they both have an n. And then we write down everything else after that. So now we're looking at the groupings. What do n squared and minus 1n have in common? Okay, hopefully you see that they have an n in common, leaving me with an n minus 1, right? When I take one n from there and one n from here, I have an n minus 1 in common. And what do minus 10n and a plus 10 have in common? Okay, and believe it or not, they have a minus 10. Okay, they have a minus 10 in common. So I'm going to take the minus 10 away, and that leaves me with a positive n. And if I divide positive 10 by negative 10, my answer is negative 1. Okay, so the way that these factorizations work, these two things in parentheses, right, your leftovers should be the exact same. If you've done your thought process correctly, those two things, those two leftovers will be the exact same from both of your terms. So we get the n minus 1s collected together as a single factor. We get the blue stuff collected together as the other single factor. And then we have all of this with a 2 out front. So we can put a 2 right here. And that is the complete factorization of this quadratic. Okay, let's try another one. M squared plus 2m minus 24. Okay, so our a value is 1 because there's 1m squared. Our c value is negative 24. So 1 times negative 24 is negative 24. And our b value, the number in front of just your variable, is positive 2. Okay, so we have a negative product and a positive sum, which means your positive multiplier will be greater. Okay, because the only way to get a negative product is with a positive and a negative. Right, that's how we get a negative product, is if one of our two numbers are negative. So let's think about all the numbers that multiply to give us 24, where the larger number is going to be positive. Okay, so that's 24 and 1. That's 12 and 2. That's 8 and 3. And that's 6 and 4. Right, those are all the numbers that multiply to give me 24, with the larger number being positive. So 24 minus 1, that's 23, right? That's not going to work. 12 minus 2 is 10. Nope, that's not going to work. 8 minus 3 is 5. Nope, that's not going to work. 6 minus 4 is 2. There it is. Those are going to be my factors, right? Those are the numbers that multiply to give me negative 24 and at the same time add to give me 2. Okay, so that's the important thing, right? They call them magic numbers. They're just numbers that have multiple jobs. So I have m squared plus 2m minus 24. And I'm going to split my 2m into 6m, right, plus 6m and minus 4m. 6m minus 4m is positive 2. Okay, and then I have my other terms. I have my m squared and the minus 24. So now I'm looking at these first two terms and my second two terms. What do m squared and 6m have in common? They both have an m as a multiplier. Right? So I take 1m away from here and 1m away from there. M plus 6. And what do negative 4 and negative 24 have as common multipliers? Right, hopefully you know they have a negative 4. If this term is negative, then your factor out here is going to be negative also. Okay, m plus 6. Because what's negative 24 divided by negative 4? Well, that's a positive 6. Right? In addition, I want my parentheses to be the exact same. So if your left parenthesis has a plus sign in it, then your right parenthesis better have a plus sign also. So we're going to have to do some manipulation in order for that to be the case. So m plus 6 is one factor, and m minus 4 is your other factor. Remember, factors mean multipliers. If I were going to redistribute all of this stuff here, right, my answer would be that. If I were to multiply m plus 6 times m minus 4, my quadratic would be m squared plus 2m minus 24. And that's what we're looking at, what things multiply together to give you that. Okay, let's try the back. Flip it over and see what we got. Okay, what's missing here with number 4? We have an x squared term, and we have a constant term, but we're missing the b term. So we're going to throw in a 0 as the b term. Okay, 0 as the b term. So a times c is 1 times negative 25, and our b term is 0. So what numbers multiply to give me negative 25, but also add to give 0? Right? So let's see what numbers do that. I guess the multipliers are going to be negative 25 and 1. Negative 25 times 1 is definitely not 0. What other numbers do we have that multiply to give us negative 25? Negative 5 and positive 5. Negative 5 times positive 5 multiply to give us 0. Okay? So this is how one of these strange ones works, x squared plus 0x minus 25. I'm going to split my 0 into 5x and a minus 5x. Okay, so I have no term in the middle, which means it's going to be a 0. So x squared plus 5x. These have an x in common. Right? And if I take an x out, I have x plus 5. And negative 5x and negative 25 have a negative 5 in common, right? They both have a minus, so we factor the minus out. Negative 5 divided by negative 5 is positive 1. Negative 5 divided by negative 25 is positive 5. Okay, so one factor is x plus 5, and the other factor is x minus 5. Okay, so these ones are strange, right, because it doesn't have all the terms to begin with. So we have to deal with that in putting a 0 into the middle, right? There are 0 x's, so we have a 0. And that splits into a positive and a negative. Okay? Okay, our a value in this one, the a is going to be 6 and the c is going to be 3. Sorry, that needs to be a c. So 6 times 3 is 18, and our b value is negative 11. So we're looking for numbers that multiply to give us 18 and add to give negative 11. We have a positive product but a negative sum, which means both of our multipliers need to be negative. Okay, a positive product but a negative sum means our multipliers have to both be negative. So 1 and 18, nope, that's not going to work. 2 and 9, sure enough, 2 times 9, well, that's negative, there we go, that's the one. Okay, so that splits. Rewrite our quadratic and split the negative 11 into negative 2x and minus 9x plus 3, 6x squared. So now we look at our common factors. What do 6x squared and minus 2x have in common? Well, they have a 2 as a multiplier and an x as a multiplier. So if I divide this by 2x, I get 3x in here. And then if I divide that, I get a minus 1. Okay, now looking at minus 9 and plus 3. Remember, if this is a minus, this becomes a minus also. So if I divide this by negative 3, well, that's a positive 3x. If I divide that by that, it's a minus 1. So notice once again that my parentheses here are the exact same. And that's the way it's supposed to be. So one factor is 3x minus 1, and the other factor is 2x minus 3. Okay, so this is called the AC method. You multiply your first term by your last term, and you're looking for numbers that add to give the middle. We take those numbers and we split that middle into those two multipliers, and then we do common factoring to get our final answer. Okay? This is called the AC method. Have a great day.